Bismillahirrahmanirrahim. Welcome back, students. So we are going to continue this lecture 16 where we were discussing recursion. So there are two types of recursive function: the direct recursion, where one function is calling itself again and again, and then today we are going to see what is indirect recursion. So indirect recursion is where one function, for example a, calls b, and the function b again calls a. So this is called indirect recursion. So we are going to see practical example of indirect recursion. But first, let me once again define it. When a function calls another function and that function calls the calling function, then this is called indirect recursion. For example, function a calls function a calls function b, and in return function b calls function a. So you will have a better understanding when we practically run this example. So I'm going to go to my editor and let me create a new project. Let me select console application, C++, and then here I'm going to write indirect recursion, and everything is fine. And let me open this project. Let me delete the default code. Let me zoom in, and here I'm going to write, and we are going to see an example of an indirect recursion. So let me first declare a number. Let me assign it some value of 5, and here I'm going to say cout. I'm going to call a function and pass it on this number, and the function is f of a. So function a. So where is function is? Let us define it at the top. So I'm going to declare function a, and it is going to accept an integer. I'm also going to declare function b, and it will also accept an integer. So as both these functions are declared at the top, so we can write the definition of both these functions below this main function. Okay, so first let us write the function a, int a. So yes, because it is accepting a number, so I can write f of a int n, and then we can write something inside this uh, function a body. So if once again we have base condition n is less than or equal to 1, so then what should happen? We will be returning the value of 1. Else we are going to return, here I'm going to like it is same as the previous example, but here I'm going to write f of b, which is another function n minus 1. So that is why it is called indirect recursion, because f of a is calling f of b. So where is f of b? So let us define it. So integer f of b, and here we can write, let me get some space, here we can write so I'm going to zoom out because I'm having some difficulty in writing the code. So we have f of b int n, so f of a is calling f of b, and then once again we have this base condition. If n is less than or equal to 1, then we are going to return 1. Else we are going to say return n multiplied by f of a. So here we are calling the f of a function n minus 1, and the rest is same. And that is why it is called indirect recursion. So first f of a is calling f of b, and f of b is once again here calling f of a. F of b is calling f of a. Okay, so with that, let me compile this program. Let me run it. And here you can see that the factorial is 120. So if I like change this number to, let's say, 10, so compile it, run it, so you can see this is the factorial of the number 10. You can also, like, from here you can compile it and run it at once, but you can also prompt the user to enter any number. So here I'm going to write enter any number to finds its factorial. And here we can use cin statement, cin num, and then we pass on that value num to function for f of a. F of a calls f of b, and f of b calls f of a, and this routine is repeated again and again until we have a base condition, until a base condition is met. So this is what this is what the indirect recursion is. I'm going to, like, for the sake of understanding, um, I'm going to we are going to practice, and I'm going to create another project. So file, new project, and in this project we are going to see how to find a table of a number using recursion. So uh, generating table of any number using recursion. Okay, so a new project has been created. Let me delete this line. And because we are finding uh, a table of a number, so let me first declare a num variable, and then I can say that initially we have n variable, n is 1, and we also have one variable for the result. Then I'll ask the user into any number. So the user enters num, and then we call a table function, and we pass it the number, the value of n, and the result variable. Okay, so with that, let me also declare this function. So this function is a void function. It will return nothing, and then it is accepting integer, integer, and integer. All right, so let me define that function. Remember, we have function calling, function declaration, and function definition. So void table, so it is accepting a num here is different from this num. This num is local to the main function, whereas this num is local to the table function. And then we have the value of c, and then we have result. So these variables are different from the variables you see in the main function. Alright, so if we have condition, if c is less than or equal to 10, then, so this is the condition, then inside the if condition, the if statement, we first initialize result to, so what was inside the result? So initially I can say that result is equal to 0. So but now result is equal to num multiply by c. Alright, so then what can we do? We can simply display that num, which in our case is 1, is yeah, it is any number that the user has entered. So let's see, it's 10, so 10, and then we are going to display multiplied by c. So c here is 1, and then we can, okay, put double quotes, equal signs, again put double quotes, and here it will be the result. So num multiply by c. So 10 multiplied by 1 is 10. So okay, this is the result. So 10 multiplied by 1 is 10 multiplied by 1, which is 1, which is 10 in fact. And at the end, I'm going to again call this table function, and this time I'm going to pass it num, and then I'm going to pass c plus 1, because we have to go up to 10, and then also the result. So again we are calling this table function from inside of this, the body of the table function. So here num is still 10, c plus 1 is 2, and the result is having value of 10. So these values are passed here. So 10, 2 and 10. So here, yes, 2 is still less than 10. So what we do, we multiply by 10 multiply by 2 into the result, and then we display that result. I'm going to compile it and run it. Enter any number, so I'm going to enter 10. So you can see a table of 10 using recursion, but you can like enter any number. It is not that you should always enter one specific number. So let me here enter 5. So this is the flexibility of function, like you enter any number that you want. So let me enter 100, so you will get table of 100. And if I just change it to, for example, 20, so it will run up to 20. Let me enter 5, so you see that the table of 5 up to 20 has been generated using the recursion. Okay, so let me clarify one point, that these num variable, this num variable, this n variable, and this result variable are local. They are local to this main function. It means they are only visible within this boundary, this opening and closing curly brace. Whatever is outside of this main function will not see it. Here in the function call, we are just throwing the value of num, which was the number entered by the user, n, which is initially 1, and then result, which is 0. So these values are copied here, but these num, c, and result are local to this table, so they are local variable. These variables are local to main function, whereas these variables are local to the table function. These variable can only be used inside table function, whereas these variable can only be used inside the main function. If you declared some variable like int x over here, so they are called global variable. In this case, both the main function and the table function can access the value of x and change it. So change will be reflected on the both of these functions. So that's it for the recursion. I'll see you in the next lecture.